Good morning, everybody. I hope you enjoyed the Zoom video yesterday. If you went there, if you watched it, whatever. But I know that I may have left some gaps, and so I just wanted to touch on some things really quick. Yesterday's key points for us to talk about radians versus degrees. Now, degrees are the units of measure that we've used for angles up until this point, and but now we're introducing this idea of radians. Now, yesterday I talked about how one radian, was like the idea of taking the radius from a circle and kind of bending it along the exterior of the circle, and that would make up 1 radian. Now, I did my best to explain it, and I know it was kind of crazy, but I'll tell you, the book's definition is even crazier. It's right here. They give this illustration, and they say, in a circle, a central angle that cuts off an arc equal in length to the radius of the circle has the measure of 1 radian. Now, I don't think that definition is very easy to follow, especially because we will pretty much never talk about 1 radian. Yesterday in class, we talked about the idea about how it takes 2 pi to get all the way around. So every time we talk about radians, you can pretty much guarantee to see something in terms of pi. Now, our book once in a while did problems where it said 3 radians or 4 radians, but those were so rare because I don't know if you guys remember from yesterday, we said that 1 radian was actually equal to something like 57.285 ... some crazy angle. And so when was the last time you said, well, hey, let's pick an angle at random? I don't know. How about 57.285 something? I mean, you just wouldn't randomly pick that. And so in the same way, 1 radian is just not that useful. Even weird angles, even if we were to pick an angle that's not very pretty, like let's say we said, I don't know, how about something like 66 degrees? We said, well, theta is 66 degrees, and we said, well, let's convert that to radians. Well, like we said yesterday, to convert to radians, you just simply multiply by pi over 180. So if we took pi over 180 and we multiplied that times 66 degrees, or 66 for that matter, because 180 is really 180 degrees, so the degrees are going to cancel out, we would get 66 pi over 180. Now, 66 pi over 180, that actually does reduce. That would reduce down to 11 pi over 30. But what my point is even with a weird angle like 66 degrees, it's still going to leave us with pi. There will be a pi involved in some way. And so that's something we can kind of count on. So when we're looking at something in terms of radians, we will see pi. If we're looking at something in terms of degrees, we will see this degree symbol. Okay? I want to do one example for you this morning, and then hopefully this will be a great lead into your homework. And so what I want to do is let's take a look at exemple numero uno. And it says, if theta is 240 degrees, then first, draw theta in standard position. Second, convert to radian measure using exact values. And third, name the reference angle in both, well, it says is both. We're supposed to name the reference angle in both degrees and radians. Okay, sorry for the typo or the writing it wrong. So first, let's start. Let's go ahead and graph 240 degrees, or draw 240 degrees in standard position. 240 degrees in standard position, think about that, it's bigger than 180. 180 would take us all the way to this point right, well, hang on. 180 would take us to this point right here, and so 240 would be a little bit past that. It would get us to about there, all right? And so we could say that that is theta. Boom. Theta is drawn in standard position. Now it said, go ahead and convert theta. If theta is 240 degrees, let's go ahead and convert that to radians. Well, all we have to do is multiply that times pi over 180 degrees. And when I do that, I get 240 pi over 180. Notice the degrees cancel out. The zeros also cancel out, and so I'm left with 24 pi over 18. We go, well, what number goes into both 24 and 18? Well, that easy one would be 6, and 6 goes into 24 4 times. 6 goes into 18 3 times. So 240 degrees is the exact same thing as 4 pi over 3. That's the end. Well, then lastly, the last thing we were asked to do is name the reference angle in, not is both, in both degrees and radians. And so we look at this picture and go, okay, remember, reference angle is how can we get to the x-axis, back to the x-axis as quick as possible. And so that would be this angle right here. Now we knew it was 180 to get to this point, so this other point right here would have to be 60 degrees. Okay, and so we'd go down here and we say, well, so this was part A. This was part B. So then when we get to part C, naming the reference angle is 60 degrees. But it also asks us to name it in terms of radians. And so you'd go 60 degrees times pi over 180 degrees, which would give us 60 pi over 180, which reduces to pi over 3. And there you go. And so now here the reference angle in degrees is 60 degrees. The reference angle in radians is pi over 3. And that's what we're looking to do. So here's your homework assignment. Let me scroll on down. What I'd like you to do for homework is I'd like you to do the same thing. I'd like you to draw an angle in standard position. I'd like you to convert to radian measure using exact values. When it says exact values, that means use pi. Don't give me some crazy ugly decimal. And then lastly, name the reference angle in both degrees and radians. Okay, this should be real straightforward. Notice what's missing from this list is you're not finding the trig value of all of these. So this is going to be way quicker. You just draw the angle, convert it, and then name the reference angle in both degrees and radians. If you get any questions, email me, but hopefully this will be real straightforward. Have a great day.